Hello folks, and welcome back to Taking the Tech Exam with WM7X. Today we're going to talk about some of the most basic parts inside your radio, switches and fuses. And we're also going to start showing you circuit diagrams, which are called schematics. We're going to be seeing a lot of them in the future, so it's time to start getting used to them. And when we draw schematics, we just use lines to represent wires. And as you know, wires carry electric current, just like pipes carry currents of water. And of course, we'll need batteries to supply that current, and they're kind of like water pumps. They provide the push for electric charge to move through a circuit. And in schematics, the symbol for a battery is just a series of long and short parallel lines. Okay, now that we've got a battery and wires, we're going to want to be able to turn things on and off. So we've got switches. They're kind of like shut-off valves in the water world. And if you look at the symbol for a switch, it looks like two pieces of wire with kind of like a drawbridge in between. And electricity can't make it from one side to the other while the drawbridge is up, so we say that the switch is off in that case. But we can lower the drawbridge to connect the two ends and let electricity flow. So now the switch would be on. And if we look inside an actual switch, it's a similar idea. There's a metal pole, and it moves to connect one side to the other, kind of like the drawbridge going down or up. Okay, and when we move the pole to make a connection, we say we're throwing the switch. And because there's a single pole and a single way to throw the switch, we call this a single pole, single throw switch, or SPST for short. Okay, going back to the water world, let's say we've got a single water spigot, but we've got two hoses. One goes to the flowers and another one goes to a tree. We could use a diverter valve, like the one I've shown here, to pick which hose gets the water. And in the electrical world, you might do a similar kind of thing. You might want to choose between two circuits, one with a red light and one with a green light. And these kinds of switches, they still have a single pole, but you can throw it two different ways. You could throw it towards the red or towards the green. So for obvious reasons, we call this a single pole double throw switch, or SPDT for short. And the exam really just wants to be sure you know which kind of switch is which. So we just learned that SPDT, single pole double throw, they take one circuit in and let us choose between two circuits out. And when we look at component 3 in the figure, we see just a single pole and we see just one way to throw it. So that's a single pole, single throw switch. And figure 3, by the way, is your first schematic. So we'll get back to schematics in a minute, but before we do, let's talk about fuses. They've got one job in life, and that job is to protect your equipment from damage. There are parts inside your radio, well, all parts can only accept a certain amount of current. And if you allow more current than that to flow through them, they will burn up, like literally, smoke, fire, the whole deal. So fuses prevent that. They don't let anything else burn up because they literally will burn themselves up if too much current tries to pass through them. But they do it in a completely safe, completely controlled way. And when they do blow, it's kind of like a switch. It's a permanently turned off switch, so no more power can flow. So if we've got a circuit that can only handle 5 amps, we'd use a 5 amp fuse. And if more than 5 amp tries to pass through, it'll burn up and it'll keep the rest of your circuit safe. All right, so we'd never use a 20 amp fuse for a 5 amp circuit because a 20 amp fuse won't burn up when 6 amps flows through it or 5.5 amps blows through it. So a 20 amp fuse is no good for a 5 amp circuit. We always want the rating of the fuse to match your circuit. All right, so that's fuses in a nutshell, and the exam covers just the fundamentals that we talked about. They want to know that the whole purpose of a fuse is to protect other components from overloads, so you got that one. And this question is really just asking the same thing in a slightly different way. And of course, we'd never want to replace a smaller fuse with a bigger fuse because that could cause your circuit to burn up. Okay, speaking of circuits, let's make a little circuit out of the parts we've been talking about and look at how electricity would flow through it. All right, current would flow from our battery through the fuse, the switches, it would go through the green bulb and then back to the battery. Okay, so very simple circuit. But this isn't the way we draw schematics. For one thing, we don't use pictures of the parts. We use the symbols that we've been seeing along the way. So here's the same thing as an actual schematic. And we've replaced the pictures of the parts with their symbols. And we can actually arrange them on the page whatever way we want to, whatever way is convenient. Schematics are all about how the components are connected to each other. That's the important thing. All right, and we'll see a bunch of schematics in the future, but that's the basics. And with that, you know enough to answer a couple more of the exam questions about them. So first off, they want you to know that a schematic is a wiring diagram using the standard symbols, not the pictures. And the only thing we focus on in a schematic is the connections between the components. That's really what a schematic is about. All right, it was fuses and switches this time, and next time we'll get into resistors, capacitors, and inductors, and that's a biggie. As always, if you have questions or comments, please leave them below. And if you want more tips on how to join the hobby or to upgrade your license, please click the subscribe button and ring the notification bell. We'll see you next time.